All right, so this is the practice test for Unit 12, Geometric Reasoning with Circles. This is part 2 of what we've studied here. And before we start in on this, I would just want to make sure we're clear. So we're going to do some arc length and we're going to do some area of sectors and stuff like that. Let me get my highlighter showing. There we are. So we need to know a couple of formulas. Now, it was probably mentioned in class, you can either memorize them or just kind of have understood how they work and stuff like that. But you'll notice that we've got some angles in degrees and some some angles in radians. So if we're working in degrees, let's just make sure this is clear. The arc length formula is going to be, we're going to need the angle in degrees divided by 360, and then we do 2 pi r. And that's going to be the fraction of the circle right here times the formula for circumference, which is 2 pi r. And then the formula for arc length is going to be the same type of thing. It's the fraction of the circle, so there's 360 degrees right there. And then pi r squared, because that's the formula for the whole area of the circle. Well, the cool thing is if you're working with radian, the formulas are a lot easier. So the formula for arc length in radians is just theta times r. And then the formula for area of a sector is just theta over 2. So we take the angle in radians divided by 2, and then we multiply that by r squared. So a heck of a lot simpler than this mess right here. I'm going to work with both of them. And you do not have to have, it's not like you have to have all of these memorized. Just pick one and go with it. It would be nice if you could kind of reason your way to why each one of them work the way they do. But I'm going to do anything in degrees I'm going to do with these formulas, and anything in radians I'm going to do in that formula right there. So here we go. It says find the arc length. Use pi on your calculator, round to the nearest hundredth, and include the units. So notice that this is in inches here. So I'm going to do arc length. It's going to be 45 over 360. Those are both in degrees, but those would cancel off. And then we're going to do 2 times pi times r, and that's going to be 9. Technically in inches, if you put that now or put it later, that's totally fine. And then what I'm going to do is I'm going to pull up the calculator and just have it compute what the answer is. So let's see what we get here. So I'm going to do 45 divided by 360, and then I'm going to times that by 2 times pi times r. And r is 9 right here. So there's the expression, and then I get 7.068. So this is going to be 7.07, and I put the right units on there, so 7.07 inches, because it's kind of like a story problem. We probably had to simplify as much as we can here and help make sense of it. And then this next one is arc length, but you'll notice that this is 4 pi thirds. So that's in radians. There's no degree symbol on there, so it's a real number. There's no units on it or anything like that. So the arc length formula is just theta times r. So this is going to be 4 pi thirds times 10 kilometers. So I'll put the km on there if we need to. Now, again, you could just circle that and say, well, that's kind of the answer, but we have to tell people what the answer is. We have to tell them, hey, this is how long this arc length is. So again, I'm going to pull up the calculator, and we're going to make sure that we plug things in correctly. So I'm going to do 4 pi, we're going to divide by 3, and then we're going to times that by 10 and hit enter, and we get this 41.887. That 7 is enough to bump this up. So it's either going to be 88 or 89. It's definitely going to be 89 in this case. So we're going to do 41.89, and that would be in kilometers. So we've got our answer right there. All right, these next two problems, area of a sector. So we need to use this formula right here, area of a sector there in degrees, or area of a sector here in radians. So this is going to be A equals 90 degrees but divided by the 360 degrees. If you want to reduce that and say that's 1/4, you're totally welcome to. And then it's going to be pi times r squared, so that's going to be 12 feet, and we're going to square that. So I'm going to type it in just like this. So we're going to type in 90 divided by 360. If you want to make that 1/4, you're welcome to. We're going to times that by pi, and then we're going to multiply that by 12 squared. Looks pretty good there. So I get 113.097. So it's either 9 or 10 if you want to think of it that way. So this is going to be 10. So this is going to be 113.10, and this is going to be square feet. Okay, so we'll say we got our answer right there. And then this one, this is 3 pi fourths, not 4 pi thirds. This is 3 pi fourths, and then the radius is 15. So on this one, when we plug into the formula, this is going to be 3 pi fourths. We're going to divide that by 2, and then we're just going to multiply by r squared. So this is going to be 15 centimeters squared. You'll notice that there's no units here to cancel or anything like that, but what I am going to show you here is when we have a fraction divided by another number or a fraction divided by a fraction, we think of this as we call this a complex fraction. I'm going to flip this one over. We don't divide by the second fraction. We flip it over and we multiply. So I'm going to multiply by 1/2. So I'm going to rewrite this as 3 pi eighths and then 15 centimeters on the inside, and then we're going to square that. So you'll notice if we think about this, if I do half of 3 pi fourths, that would be 3 pi eighths. Okay, if you cut fourths in half, you get eighths. Okay, so I'm going to type this in. I'm going to do 3 times pi, and then we're going to divide by 8, and then I'm going to times that by 15, and we're going to square that. And we end up with 265.071, and this is either going to be 7 or 8. That one's not enough to bump it up, so here's what we end up with. We end up with 265.07, and this is going to be in centimeters squared, okay? So we'll go ahead and circle that, and there's our answer, and then I'm going to slide down here and take a look at the next couple. This says sketch each sector and then find the arc length and the area. So we have to do arc length and area. And same thing, round to the nearest hundredth and include units. So on this one right here, let's see 240 degrees. So 90 would be right here, 180 degrees would be right here. We should be pretty good at this by now. So this is 240 degrees right here. And this is a 10-foot radius. Again, straight down here from standard position, this would be 270 degrees. So we want to find the arc length and the area. So remember, the arc length is going to be 240 divided by 360, and then 2 pi, and then the radius of 10. And then the area is going to be 240 divided by 360, and then it's going to be pi r squared. So we got a 10 squared right here. If you want to take the time to simplify, there's no problem doing that. I'm going to go ahead and cancel those off. In fact, I didn't do any cancellation above. 24 over 36, that's actually 2/3. So let's see, 2 on the top because 12 goes in there twice, and 3 on the bottom, so 2/3. So here's what we're doing. We're doing 2/3 times 2 pi times 10, okay? And then on this one, we're going to do the same thing. This is going to be 2/3 of pi and then r squared, which is 10. Let me put a 10 in here. Sorry about that. Okay, so you'll notice what we've got here is we've got this fraction of the circle now going through this, and then we just throw this into the formula. Let me make that look like a 10, or throw that into the calculator. So this is going to be 2/3 times 2 pi times 10, and hit enter. We get 41.887, so that's going to be 41.89, so 41.89, and that's in feet because we're talking arc length. That's just that unit right there. And then we're going to do, let's see, that'd be 10 feet squared, and then we've got the 2/3, so we're going to do 2/3, and then we've got the pi, so I'm going to hit times by pi. I don't have to do that, but it's just kind of nice to put that in there. And then I'm going to do parentheses 10, and I'm going to square it. You could just throw in a 10 squared, and that would be fine. And I got 209.444. Okay, so we get 209.44. And then remember, because this is area and this is measured in feet, this is going to be square feet. Okay, so there's the answer there. Now, turn our attention to this one. Remember what the formulas are here. We want to represent what this looks like. It says sketch each sector. So pi would be over here. That's just the top half of the circle. So if we're finding the arc length, we're finding how long this is right here. So the formula is, it's just theta, so that's going to be pi times the radius, which is 5 yards. So we throw that in the calculator. So we're going to do pi, we'll hit second and pi times 5 and hit enter. And we get 15.707, so that's going to be 15.71, and that would be in yards because we're just measuring how far along the outside edge. And then the area would be this area in here, that sector. It's like half a pizza there. So the formula for area on this is going to be pi over 2. Remember, we take theta, divide by 2, and then we do times r squared. So in this case, this is going to be 5 yards, and we're going to square that. So we'll throw that in the calculator. So we're going to do second pi, we're going to divide by 2, and then we're going to times that by 5 squared. Hit enter, and we get 39.279. So this is going to be 39.269, so 27, okay, and that would be yards squared, Okay, so I'm going to put a box around that, and there's our answer there. And let's take a look at these guys here. So I'm going to make this a little bit full size for a second. And what we want to do here is we want to find if L is arc length and A is area of the sector, find the missing piece of information, round your answers to the nearest hundredth. So we've got a radius of 11 feet, we've got an arc length of 60.48 feet, and what we're missing is we're missing the angle. So the formula here, and you'll notice that it doesn't say that we have to do this in degrees or radians. So let's go ahead and do this in degrees, just for the heck of it. I think a lot of people tend to be more comfortable with degrees when they start off here. So this is going to be theta over 360, and then this is going to be 2 pi r. And in this case, we know the arc length, 60.48. And let's see, yeah, this is going to be feet. I'm going to put the units on here. We don't know the angle. We do know this is 360, and we know that this is 2 pi, and then this is 11 feet. So what I'm going to do here is I'm going to take this, and you can throw this in the calculator if you want to, and you can get an ugly decimal for these. But what I'm going to do is I'm going to multiply both sides by the reciprocal. I'm going to multiply this side by a 360 degrees on the top, and a 2 pi. 2 pi times 11 feet on the bottom. So I'll do that on this one also. So I've got a 360 on the top, and I've got a 2 pi times 11 feet on the bottom. And I want you to take a look at what happens. So the 360s cancel, the 2 pi's cancel, the 11 and the feet cancel. So the only thing left over on this side is just theta. And notice that over here, the feet cancel, and the only unit left would be degrees. So let's see what we've got here. I'll pull this over here, and we'll throw this into the calculator. So we're going to type in 360 times 60.48, and then we're going to divide that by, and when I divide by more than one factor, I want to make sure that I put that in parentheses. So this is going to be 2 pi times 11. And we're going to hit enter on this, and hopefully we get something decent here. So this is 315.02. All right, so this is going to be 315.02. And remember, this is what theta is. So this has got degrees on it, and the units work out like that. Okay, so I'm going to put a box around that guy right there. And then we'll take a look at this one right here. So this is another arc length. Okay, so they didn't give us an area here. So I'm just going to type this in this way. The arc length is 61.26, okay, and then theta is 270 over 360, and then the formula for arc length is 2 times pi times r. So the only thing that we're missing here is just the r, and let's see what we get. I'm going to take both sides of this, and I'm going to multiply the sides by, let's see, a 360 on the top, and a 270 times 2 pi on the bottom. So notice the 270 and the 2 pi would cancel, and the 360 would cancel. So I just need to multiply over here by a 360 on the top and a 270 times 2 pi on the bottom. Okay, let me make that look just a little bit better. Let's see. So a 360 and a 270 times 2 pi on the bottom. So I'll grab the calculator and we'll throw that in. So 360 times 61.26, and then we're going to divide that by, in parentheses, let's see, 270 times 2 times pi, whoops, not alpha. There we go. Okay, so I think I've got everything in there the right way. We got that on the top. Okay, that looks good. So I get 12.999. So we were looking for a radius here. So the radius on this one is going to be, we're going to have to round that up to 13. So r equals 13. And again, because this was in yards, this is going to be in yards. So 13 yards here. If you wanted to put 13.00, that would be totally okay. Okay, let's take a look at the other side. Okay, on the other side, we want to convert from radians to degrees or degrees to radians, and it says leave answers in terms of pi when it's applicable. So remember, the conversion factor we're using here is the fact that 180 degrees equals pi radians. So if that's the case, we can do 180 degrees on the top and pi radians on the bottom, or If we need to convert the other way, we can put pi on the top and we put 180 degrees on the bottom. Now, I'm hoping most of these look pretty familiar. There's a few that may not. So 135, we want to change that from degrees to radians. So I'm going to multiply by, put the 180 degrees on the bottom so that those will cancel, and we end up with a pi on the top. So the degrees will cancel, and then 135 over 180, hopefully everybody's familiar with this by now. 45 degrees goes in here 3 times. 45 degrees goes in there 4 times. So that's 3 pi fourths. We want to change 5 pi thirds into degrees, so I'm going to take the conversion factor and I want to cancel off the pi. I want the degrees to remain, so 180 is going to go on the top and pi is going to go on the bottom. The pi's will cancel. 3 goes in to 3 once. 3 goes in here 60 times, so if I multiply those together, I end up with 300 degrees. Okay, so that's what I get when I convert there. Let's see, the next one, 2 pi. This one shouldn't be bad at all. I'm going to put, I'm going to put 180 on the top. I'm going to put pi on the bottom. Those are going to cancel. Now we should know that 2 pi is all the way around the circle, so that's going to end up being 360 degrees. Piece of cake there. 75 is not a common angle, so let's see what we've got here. I need to multiply by, let's see, I need to cancel the degrees, so those are going to go on the bottom, and I want to change it into radians. So I need to have something that goes in here evenly. If you want to grab a calculator and do this, that's totally fine. But 5 goes into both of those. Let's see, 5 goes in here, that would be 15 times, and 5 goes in there, I believe that's, I think 30, what would that be? 36 times? I think that's right. And then 3 goes in here 5 times, and 3 goes in here 12 times, and then we've still got the pi on there, don't forget that. So that's going to be 5 pi 12ths. Not a common angle, but we should still be able to convert that. If you know this one off the top of your head, that's great. It's 7 pi 6, but let's just double check and make sure. Pi on the top, 180 degrees on the bottom. Let's see, I can cancel the zeros, and then I've got a 21 and an 18. 3 goes in here 7 times, 3 goes in there 6 times, so that's 7 pi 6. There's our answer. We'll do the same thing on this one. We're going to do pi, and then this is 180 degrees. We're going to cancel the 0, so I've got 24 on the top and 18 on the bottom. 6 goes in here 4 times, and 6 goes in here 3 times. So this is 4 on the top, 3 on the bottom, and then we've still got the pi right there. And then 7 pi 12ths. Again, not one that we might recognize, but let's see what we can do about this. There's no unit on here, so we know this has got to be in radians, because radians, that's the only measure for an angle that is a real number. So we're going to multiply this by 180 degrees over pi. So the pi's are going to cancel, and then I've got 180. I'm going to cancel, let's see, 6 goes in here twice, and 6 goes in here 30 times. Yeah. And then 2 goes in here once, and 2 goes in there 15 times. So let's see what we've got here. Those all cancel. So I've got 7 times 15. Let me grab the calculator really quickly. I think I know what that is. 7 times 15 is 105. So we get 105 degrees on that. Okay. And then the last one, pi fourths. Again, it's probably one you're familiar with, but if not, we can always do the conversion. Whoops, the pi's are going to cancel. We're going to have 180 degrees divided by 4. So we end up with 45 degrees, okay? Now, we've got all the common angles going around the circle in radians and in degrees. So we should be really good at this point. This is a great problem. So I'm going to start in degrees, and you can do this however you want. I mean, if you need, like for this one right here, it's 30 degrees. If you need to come over here and say, oh, that's plus 30 going this way and minus 30 going this way, so we've got 180 degrees right here, and I subtract 30 and all that sort of stuff. You can use symmetry and all sorts of stuff. I'm hoping at this point you can just rattle off what they are, because they're multiples of 30 and 45 and 60. So here we go. 0, 30, 45, 60, 90 would be the next one, and then we'll drop down here, so we've got the degree symbol right here. This is another 30 degrees, so 120, 135, because that's a multiple of 45, and then this is 150, like we said just a second ago. This one's 210, this one's let's see, 15 degrees here, because this is just a smaller piece right here, 225, 240 for this one, and then we get down here to the bottom, 270, and then this is going to be 300, 315, and you can reason your way to that a couple of different ways. This is 360 all the way around the circle, but if we subtract 45, that would put us at 315. And of course, this is 330 degrees right here. Now, if I go around the outside and I label the radians, 0 radians, This is going to be pi sixths. This is going to be pi fourths, pi thirds, pi halves. Okay, and then over here, this is 2 pi thirds. This one is 3 pi fourths. This one is 5 pi sixths, and this one's pi. And then we have 7 pi sixths. This one is 5 pi fourths. This one is, let's think about this right here. This one is 4 pi thirds. This one is 3 pi halves. And then let's see right here, this one's going to be, this is a multiple of 60, so this is going to be 5 pi sixths. No, 5 pi thirds, 5 pi thirds. Okay, and then this one is 315 degrees, that's a 45. That's going to have to be, it's going to be 7 pi fourths. Okay, and then this one is 330 degrees, so it's going to be a 6 somehow, and it's going to be 11 pi 6, and then all the way around the circle we get 2 pi. Now, if I were to go through here and count, hopefully the degrees are pretty easy. Those aren't too hard. But the radians, we're kind of working with fractions here, but again, you've probably seen me do this before. So this is 1 pi sixth, 2 pi sixths, 2 pi 6, you can reduce that to 1/3, okay? And then this would be 3 pi sixths, reduces to pi halves, okay? This is 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6. Skip that one because that's a multiple of 45. This one is 8 pi 6. This one is 9 pi 6, 9 pi 6. Okay, you get the idea here. This one would be 10 pi 6. And you can look at it and you can tell the ones that cancel, 11 pi 6. And then this one, of course, would be 12 pi 6. And 12 pi 6, 12 pi 6, that would reduce to be 2 pi. Okay, so I'm going to get rid of those. And as I've gotten rid of these, it's not that you have to have those patterns and go through and simplify like I just talked about. As long as you've got these memorized, you're in great shape. I mean, you just have to know the relationships and stuff like that. I do want to run through and just talk about the pi fourths. 1 pi fourths, 2 pi fourths, 2 pi fourths, that would simplify to be 1/2. Then 3 pi fourths, it doesn't simplify. 4 pi fourths, it does simplify. 5 pi fourths. Okay, this would be 6 pi fourths, and that would reduce to 3/2. 7 pi fourths, and then of course all the way around the circle would be 8 pi fourths, which reduces to 2 pi. Okay, so hopefully we've got those down really well. And then we turn our attention to circles. So on these circles here, it says graph each circle, label the center and radius. So whether you label the center and radius on the graph itself or somewhere else, I'm just going to write down that the center here is 0, 0, and that the radius is 4, and then I can graph this. So I'm going to go 0, 0, and then 4 units in each direction. And then I just do the best I can for drawing a circle. I had somebody say, hey, how can I draw a good circle? Mine are really horrible. If you want to, you can put a little box around this. And for some people, that helps them because then they've kind of got some guidelines. So if I come up here and I hit this, and then I know I've got to curve around, and then I'm going to hit this, and then I'm going to curve around. If you take a look now, that's pretty crappy, but kind of bumpy. That can help you sometimes, and mine's on this stylus and the computer and stuff like that. So before I go any further, remember, this is the easiest type. We know what the center is because it's just x. We didn't add or subtract anything. Same thing with the y. But remember, this is x minus h, quantity squared, and then y minus k, quantity squared, equals r squared. And that means the center is at h comma k, and whatever this number is, then we take the square root of that, and we'll write radius equals r. So that's going to help us with something like this because we look at it and we know the center is opposite of that one's -3, opposite of that one's -5. And then the radius on this is the square root of 25, so that's going to be 5. So I'm going to go to -3 and -5, so we'll come down here. And then I need to go 5 units in each direction, so that's up to here, that's over to here. Let's see, that is 5, so that's going to put us down here at -10, and then 5, 1, 2, 3, 4, 5, right over there. And then I'm going to draw the best circle I possibly can. Okay, and mine's happened to be in 2 pieces here, so there we go. And then this one right here, again, center is going to be at the opposite of this, so that's going to be a 4. Opposite of this, that's going to be a 1. And then the radius is going to be the square root of 40. Now, that doesn't really help anybody doing that, but if we wanted to do 40 is 2 times 2 times 10, and write this as 2 radical 10. We could be really clever about this, but that really doesn't help us either. So I'm going to grab the calculator so I know about how far to go. So I'm going to do square root of 40 and hit enter, 6.32. And just for the heck of it, to make sure that I simplified that correctly, I think it's 2 radical 10. We get the same answer either way. So I'm going to say approximately 6.32. So the center is at 4, 1, so we're right here. And then I go a little bit more than 6 in each direction. So that would be a little bit over here. That would be a little bit past 7 over here. Let's see, a little bit past -2 here, and a little bit past -5 right here. And then again, we just draw the circle as best we can. And because we've got it labeled up here, then we're in good shape. Okay, let's take a look at the other side. Okay, on this side we get some interesting problems because it asks us for the equation of the circle if we've got the following piece of information. Well, this one's pretty easy, and so is this one down here because they say what the center and radius are. So this is going to be x minus whatever that number is right there, so x minus 3 quantity squared, y minus 15 quantity squared, and then it equals the radius squared. So if I take 3 and I square it, I end up with 9. So we're done right there. While we're at it, we'll do the simple one here. So this is x plus 6, don't do a minus 6, and this is y plus 3, and then that equals the radius squared, so that's going to be a 36. So a couple of easy problems right there. Now we'll take a look at this. It says the center is at the origin and it contains the point 8, 6. So that point is on the circle. So if it's centered at the origin, that means that the center is 0, 0. That's where the center is. So that means we've got x squared plus y squared. What we don't know is we don't know the radius. So the easiest thing to do is say, I've got everything on the equation except for the radius, but I know this works in the equation. It's on the circle, so it's got to work in the equation. So I'm just going to write works in equation. So we're going to throw these in here. So this is going to be 8 squared plus 6 squared equals r squared. So this is going to be 64 plus 36, and that equals, let's see, that's a 100 equals r squared. So the cool part about this is I don't need to take the square root. Yeah, I know the radius is 10, but it doesn't really matter on this one. We're just going to write x squared plus y squared equals 100, put a box around it, and then we're done. Okay, so we'll come down here and it says diameter with endpoints 2, 8 and -3, -16. So just so we get a ballpark of what this looks like, 2, 8, that would be up here. -3, -16, that would be way down here. So the circle, that's a diameter, goes around like this. Okay, and we need two things. We need to know the center and we need to know the radius. So if we need to know the center, we need to know the midpoint. So the midpoint is going to be the average of the two of these. So this is going to be 2 plus -3 divided by 2. And then this is going to be 8 plus -16 divided by 2. So I end up with, this turns out to be -1/2. And then, yeah. And then this turns out to be, this is -8 divided by 2, so this is going to be a -4. So there's the center. So here's what we know so far. We know x plus 1/2 quantity squared, y plus 4 quantity squared, and what we don't have is we don't have the radius. So in order to find the radius, let's just figure out what the diameter is and then cut it in half. Or if you wanted to, you could find the distance between the center and either one of these points. But because this center has a fraction, I probably don't want to do that. So here's what we're going to do. We're just going to find the distance between 2, 8 and -3, 16. So I'm going to do -3 minus 2 quantity squared. And then I'm going to do -16 minus 8 quantity squared. And I know this one right here would be -5 squared. So I know that's going to be 25, but I'm going to get some help on this one right here. So this is going to be 25 underneath the square root. And then let me just double check here. So this is going to be, it doesn't matter whether this is positive or negative. That's going to be a 24, and I'm going to square that. So I end up with 576. So 576. So this ends up being the square root of 201. Square root of 201, or sorry, 601. Square root of 601. That's the diameter. So I just take that and I divide it by 2. So let's see what we've got here. So that is that's the radius. That equals the radius, and we need the radius squared. So I'm going to square both sides of this, and I end up with 601 here, and if I square the bottom, I end up with a 4. So just to be clear how this works, We're squaring a square root, so those undo each other, and then we're squaring a 2, so we end up with a 4. So that right there is our answer. A little ugly, but it works. Okay, now these last couple on this page, we're completing the square to find the center and radius of the circle. So remember how this works. We're going to collect the x's together, and we're going to collect the y's together. And as we do that, we're going to leave some space to complete the square. Now, you'll notice that there weren't any constant terms here. Now, you don't have to put the parentheses on here, but I highly recommend it. I think it's a good idea. Half of this coefficient is a positive 4. I'm going to put a dotted circle around that. So I'm going to add the perfect square of that. So that's going to be 16. I'm going to do the same thing to the other side. Then I'm going to take half this middle coefficient, that's positive 3, put a dotted circle around that. I square that, so I'm going to add 9. So I'm going to add 9 to the other side also. So all the red stuff was there originally. The blue stuff is what I added. So here's what I've got. I have a perfect square of x and that number right there, quantity squared. I have a perfect square of y and that number right there, so y plus 3 quantity squared. And then over here I've got 16 plus 9, so that's going to be 25. So that means the center is at -4 comma -3. And that means the radius is 5. So we're going to go -4, slide this down just a little bit, -4, -3, and then we're going to go 5 units in each direction. So that's going to put us here, 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 and let's see, -3, this would put us at -8. Yep, I think that looks good. There's our circle. We've got the equation, we've got it labeled and all that sort of stuff, okay? So we'll take a look at this next one here. Again, do the same thing. I'm going to gather the x's together. I'm going to gather the y's together. And then I need to put that 12 on the other side, so that's going to be a positive 12. Again, everything here was in the problem to begin with. Half of this is -1, half of this is -5. So I'm going to put a box around each one of those. And then I'm going to square this, I get a 1. Square this, I get a 25. So I'm adding 25 and I'm adding 1 to both sides. Okay, so this is a perfect square of x, whoops, change colors here. Whoops, jumping all around. I think there we go. Okay, so this is x minus 1 quantity squared and plus y minus 5 quantity squared. And then on the other side we get, let's see, this is 13 between the two of those plus 25, so this is going to be 38. Whoops, 38. Okay, so the square root of 38, I don't know what it is, but it's a little bit more than 6. I mean, we could throw it in the calculator and check and see what it is. So second square root, 38, 6.61, or 16, okay? All right, so the center here is at 1, 5, and then the radius is that 6.16, okay, radical 38. So 1, 5 right here, and then we go 6 units in each direction, so 6 units down. A little bit more than 6, I guess I should make it look like that. Okay, a little bit more than 6 in this direction, a little past 7. 6 in this, a little bit more than 6 in this direction would kind of put us up here. We're off the charts just a little bit. And let's see, the last one, we're going to be -1, 2, 3, 4, 5, 6, and a little bit more. So we'd be right there. So that is what it looks like. Okay, horrible, horrible circle, but there we go. All right, let's take a look at the last page. Okay, we're being asked on this last page to verify a couple of things, and you'll notice that we don't have any, there's no axes or anything on here, and that's a little bit unsettling, but we can deal with this. I'm just going to draw a rough sketch of maybe what this would look like. So -3, 4, back 3 and up 4, so I'm going to put a dot right here for J, and I'm going to label that as -3, 4. And then K is at 0, 0, so I'm going to put a dot right there. That one's pretty easy, 0, 0, that's where K is. And then I've got 9, 3, so 9, 3 is going to be up just a little bit less than that one right there. So this is going to be L, and that's at 9, 3. And then the other one is at 9, 8. So 9, 8 would be straight above this here, okay? So this is 9, 8, and that's M. So we've got definitely a quadrilateral. Even with my crappy drawing here, it kind of looks like it might be an isosceles trapezoid. We need to check a couple of things first of all. We need to check the slopes here. Now, we would take a guess based off what we've got right here that JM is parallel to KL. So let's check the slope of JM, and then let's check the slope of KL. Okay, so the slope here would be for JM, I'm going to do y2 minus y1, so that's going to be 8 minus 4, and x2 minus x1, so that's going to be 9 minus 3. Make this just a tad shorter. So this is going to be 4 minus 3, that's going to be plus 3, so that's going to be a 12, so I end up with 1/3 right here. So I have a slope of 1/3 for that one. So we're hoping that this one matches up, so let's just check and see. y2 minus y1, so that's going to be 3 minus 0, x2 minus x1, that's going to be 9 minus 0, and we end up with 1/3. Now, if we didn't have a drawing or these were gigantic, ugly points or teeny tiny points or something like that, it would be kind of a pain to do. But we can check this other one. Let's just check and see what happens right here. If I check the slope of JK, the slope of JK would be, let's see, 0 minus 4 and 0 minus 3. So we end up with 4/3. Yeah, oops, negative 4/3. Okay. So we know that it's not parallel with the two of those. And then we can check and see what it is right here. You'll notice, because the x-coordinates are the same, this would have no slope. So the slope of ML is undefined, or we say no slope. There's no number to represent what that is. Okay, so we can tell that of the 4 slopes here, these are the only ones that could possibly be parallel. And they are in fact parallel. They're both a slope of 1/3, so we're in good shape there. The next thing we need to do, this is the best way to handle an isosceles trapezoid, is check the diagonals. We want to check and make sure that those diagonals are the same. So what's the length of each one of those? So what we're going to do is we're going to find the distance from J to L. So I'm going to do JL here. So that's going to be a big square root, and I'm just going to do x2 minus x1. So that's going to be 9 minus 3. Quantity squared, y2 minus y1, so that's going to be 3 minus 4, and we'll square that. And then I'm going to do the other one. So I've got JL, I'm going to do KM. So here's KM, big square root, and I get x2 minus x1, so this is going to be 9 minus 0, quantity squared. And then this is going to be, let's see, 8 minus 0. Okay, so 8 minus 0. So let's see what we get here. This is 9 squared. This is, whoops, I need a square on there. This is 8 squared. This right here is 12 squared. And this right here is 1 squared. Okay, so this is going to be 144 plus 1. So we get square root of 145. Now, I'm not holding out a lot of hope for this, because this doesn't really look good, but I'm going to keep that circled right there. And then let's see, this is going to be 81 plus 64. Let's see, 80 plus 60, that would be 140. And then, holy cow, this works out to be 145. Okay, so those are indeed equal. So because these slopes are the same, okay, so we've got same slope. This is parallel sides. Whoops, parallel. Okay, and diagonals equal. So I'm going to write diagonals equal or congruent. Then what I can say, I'll come over here and I'll say, therefore, this quadrilateral JKLM is an isosceles trapezoid. Okay? All right, so that's what we were after. Took all that work to kind of show it, and I probably showed a little bit more than I needed to. Let's come down here and take a look at this one. It says a circle is centered at the origin. That tells us a whole lot. And it says verify the points 1, radical 3 and 0, 2 are on the same circle. Okay, so let's do this. X squared plus y squared equals r squared. If these are on the same circle, they should work out the same when we plug those in there. So let's check and see what we get. This would be 1 squared plus radical 3 squared. That would equal r squared. And the other one would be 0 squared plus 2 squared. That should equal r squared. So this is 4 equals r squared. And this is 1 plus, let's see, square the square root of 3. That's a 3. So we get 4 equals r squared on this one and 4 equals r squared on this one. So yeah, they're both on a circle centered at the origin, radius of 3. So we're going to say, therefore, those points, 1, radical 3 and 0, comma 2 are on, let's see, we're going to call this x squared plus y squared equals, we figured out what the radius is, figured out that it's 4. They're on the same circle, okay? So I'm going to say i.e., actually let me put it in parentheses over here. I'm going to say i.e. on same circle, okay? All right, and then let's take a look at the last one here. This is number 29. It says verify that the point 3 radical 3 lies on a circle with a radius 2 centered at 2, 0. So if it's centered at 2, 0, that's going to be x minus 2 quantity squared plus y squared equals 4. So let's check and see if this actually works. Let's throw this in here. So this is going to be 3 minus 1 quantity squared radical 3 squared. Does it equal 4? That's the question. So let's see. Oh, that's a, oops. Yeah, oh, I know what I did. That's a 2. I was thinking ahead of the answer. Okay, so 3 minus 2, that's a 1 squared. Radical 3 squared. Let's check and see if it equals 4. This is a 1 plus 3 because the square roots and the squaring undo each other. So we end up with a 4. So yes, that checks out. So therefore, 3 radical 3 comma radical 3 is on x squared, we'll just say on the circle. And if we wanted to be more specific and show off, we could say it's on this circle because you told us what the formula would have to be based off the center and the radius. Okay, all right, good luck on the test.